welcome back. In the second video, we're going to be focusing on applications of trig ratios and problem solving. So the first one I have for us says the recommended safety angle of a ladder against a building is 78 degrees. A little degree symbol there. A 10-meter ladder will be used. How high up on the side of the building will the ladder safely reach? Okay. So one thing you guys have probably noticed about application problems is it's often helpful to draw a picture. So I'm not the best artist in the world, so I'm just going to have a little straight line here represent my building, and then I'm going to make a little ladder that's over here, make it look a little bit like a ladder. And then here's the ground. So the building and the ground, we're assuming this is not the Leaning Tower of Pisa, that it does right angle with the ground. That's nice and upright. Okay, the recommended safety angle of the ladder against the building is 78 degrees. So that's saying that the angle from the ground to the ladder right here is 78 degrees. A 10-meter ladder will be used. So here's my ladder. I did draw it to look a little bit like a ladder. So the ladder is 10 meters long. How high up on the side of the building will the ladder safely reach? So here's the height of the building. And that's what we're solving for. So now that I have a picture, I can see that it's a right triangle. I see that I have an angle. The side that I'm solving for is opposite of that angle. And the side that I already have a length for is the hypotenuse of my triangle. So when I look at my SOHCAHTOA, I think, well, which one has opposite and hypotenuse in it? That would be the sine ratio. So I'm going to use the sine ratio to solve this one. So the sine of my angle, sine of 78 degrees, is equal to opposite over hypotenuse. So my opposite side is the unknown. I just labeled it an x. You can label it whatever you'd like. Over the hypotenuse, which is 10 meters. And then I want to solve for the unknown side length. So it's divided by 10. The opposite of division would be multiplication. So I'm going to multiply both sides by 10. And so 10 times the sine of 78 degrees is equal to my angle. And so if I type that in my calculator, aren't you glad we have calculators, and do 10 times the sine of 78 degrees, just like that, we get that the side length is about 9.78, or about 9.8 meters. Let's do another one. The next problem I have here says a helicopter is hovering above a road. I have a picture for you this time. Very exciting. So a helicopter is hovering above a road at an altitude of 24 meters. There's the altitude. At a certain time, the distance between the helicopter and a car on the road is 45 meters. Calculate the angle of elevation of the helicopter from the car. All right. Well, angle of elevation is always the angle from the ground or a horizontal line up to an object. So that would be this angle right here. That's angle of elevation. If you ever hear of angle of depression, that's a horizontal line down to an object. Okay? So let's calculate the angle of elevation of the helicopter from the car. So I'm solving for this angle right here. So if I look at my right triangle, the side lengths that I have, the 24 meters opposite of my angle, and the 45 meters is the hypotenuse of the triangle. So again, you're going back to the SOHCAHTOA, and I think, well, which one has opposite and hypotenuse? Opposite and hypotenuse would go with the sine ratio. So the sine of my angle, x, equals the opposite side, which is 24 meters, over the hypotenuse, which is 45 meters. And if I want to solve for that angle, I'm going to do the inverse sine, so that undoes the sine here. So x equals the inverse sine of 24 over 45. And I'm going to type that in my calculator. So I'm going to do the inverse sine, just like that, of 24 over 45 and close my parentheses. And it's about 32.2 degrees. Okay, last one for us. Says a statue of the town's founder stands in the town park. Nicholas is 20 meters from the statue. If Nicholas looks up at an angle of 23 degrees, he can just see the top of the statue. His eyes are 1.5 meters above the ground. How tall is the statue? We're going to round to the nearest tenth of a meter. Okay, so yet again, let's draw a picture so that we can see what side lengths we have and how they're related to each other. So again, not a great artist, so I'm just going to draw a giant stick figure to represent the statue. Okay? And apparently we have Nicholas over here who is looking at the statue. Okay? So let's see. Nicholas is 20 meters from the statue. So the length from the statue to Nicholas, here's the statue, is 20 meters. And he's looking up, so this is from his eyes. Just going to draw a nice little horizontal line. Looking up from the eyes to the very top of the statue, that makes a 23-degree angle. Okay? And we know that his eyes are 1.5 meters above the ground. So his height from the ground to his eyes are 1.5 meters. Okay, we want to solve for how tall is the statue. So strategy-wise, what we're going to end up doing is looking at this right triangle right here, because that's where my angle is, and the 20 meters, away should be the same as this 20 meters right here. Okay? And what we can do is solve for this height, from his line of sight up to the top of the statue, and then we're going to add the 1.5 meters to get the total height. Okay? So this height right here is the 1.5 meters. So let's go about that. So if I want to solve for this height right here in my right triangle, well, that height is opposite of the 23 degrees. The 20 meters is an adjacent side. So if I'm looking at my ratios again, which one has opposite and adjacent? Well, that's tangent. So that's where I'm going to start off. So I'm going to say that the tangent of 23 degrees equals opposite, which I just labeled as an x, over adjacent, which is 20 meters. And if I want to solve for that x, I'll multiply both sides by 20. So 20 times the tangent of 23 degrees equals x. And if I put that in the calculator, 20 times the tangent of 23 degrees, that height is 8.489, so about 8.5, so 8.5 meters. And that's just this height. It's like from his eyes to the top. And then his height is 1.5 meters, so what we're going to do is add 1.5 meters to get the total height of the statue. And 8.5 plus 1.5 is 10.0. So 10 meters is approximately the height of the statue. Hopefully this helps you guys with these application problems. Just remember to draw a picture. Remember to figure out which ratio you've got. Take it slow and do a great job. You guys got this.